GM. Welcome to another First Flight introduction kickoff call. I know a lot of you here are new from Cypher and Updraft because we recently launched the security course, and one of the action items that we had you do was sign up for CodeHawks and start actually competing and start actually doing this competitive audits thing. So, welcome. Very excited to have you here. Very excited for you to begin your smart contract security journey. Or for those of you veterans who have just been enjoying the first flights and wanted to see what we cooked up this time, welcome back and good luck in this first flight. As always, what we're going to be doing is we're going to be going through the code base. This is one of the smallest, other than Password Store, one of the smallest first flights we've ever done. And this is actually a special one because this was created by Dacian, one of the security researchers on the Cypher team. And he was so compelled to make this first flight because this is actually an issue he ran into. He found in a real security review. And one of the ways he actually found the bug was by, he found the bug by doing manual review, but he said afterwards, hey, they would have found this bug if they had included fuzz tests, red fuzz tests. So for those of you who want to just kind of close your eyes, not even look at the code and just improve the test suite, this is a perfect one to do that. So take that as the challenge for this first flight. Can you write a stateless or stateful fuzzing test suite, or even formal verification if you're feeling bold, that finds this bug? Obviously, every bug can be found with manual review, but this one specifically is a perfect one for trying out your fuzzy skills. For those of you who have no idea what fuzzing is, you can check out my YouTube. We have a video on fuzzing there. We also have some articles that are going to come out very soon on the Cypher blog. And then additionally, obviously, this is in Cypher Updraft. We go over fuzzing. We go over a minimal fuzzing, stateless and stateful fuzzing example. And then we go over a much, much harder one in the T-swap section where you actually fuzz a Uniswap fork. So for those of you who want to learn, definitely check that out. So let's go over this code base. How are we doing? Welcome. I am looking at the chat. So as always, if you have questions, feel free to pop them into the chat. We have a small enough group here where we can jump into questions. For those of you who are ready for this first flight, let's get a hell yeah in the chat, please. Let me share my screen now. Eventually share my screen. Okay, here we go. Add it. Okay, cool. Oh yeah, we're getting some hell yes in the chat. That's what we'd like to see. Okay. Oops, let me stop sharing for a second. Let me start sharing again. All right, cool. So here is our code base. Let's pop open the README and let's read what this is. You can find this obviously in the CodeHawks UI. If you go to the CodeHawks UI, you go to the link associated with this contest, you will get this code base. And I have already git cloned it. So obviously this is, that's the first step you need to do. You'll need to git clone this. So let's walk through the README. Let's figure out what this code base even does. And then we'll do a quick walkthrough of the actual code. We'll do a quick walkthrough of the tests as well. So as I was saying, this is a special rendition of the CodeHawks First Flight. This was created by Dacian. Thank you so much, Dacian, for creating this one. And like I said, this is a real bug found in a real audit, in a real security review. Unlike some of our other first flights, there are way fewer bugs in this code base. There was intended to be one high in here, at least one high. So I'm giving you some massive hints already. There is at least one high in this code base. There might be more, there might be less, but there's at least one high that was intentionally put in here. If there was more, there likely are because we didn't do an actual review of this yet. But if there are more, great. But there's definitely at least one high that you can definitely find with fuzzing. So let's talk about what this is supposed to do. So this contract allows the creator to invite a select group of people to vote on something and provides an ETH reward to the 4 voters if the proposal passes. Otherwise, refunds the reward to the creator. So it's a very minimal DAO, right? And if we go to SRC, we only have one contract in here where the README kind of goes over it. There's only one contract here, this voting booth. And it doesn't have a whole lot of functions in here. It has like the constructor with the setup, but we have vote is really the only function you can really work with, because distribute rewards is a private function. And then we have some, view and pure functions at the bottom. But really, the only thing somebody can do is vote. Where's the vote function? Is vote, right? And we can even do, forge, inspect, voting booth. Let me zoom in just a little bit here. Methods, and we can see all the methods in the voting booth contract with this. This is obviously a Foundry code base. I already ran forge install, forge build, etc. We can see exactly all the different functions this has. Get creator, get total allowed votes, is active, and then vote. These are all view functions. This is the only function that people can actually call to interact with this code base. Crazy, I know, right? So that's it. You vote for or against. So in the constructor here, as we were reading in the README here, and yes, I know we're using requires, which is less gas efficient, but it was easier for readability. Right in the constructor here, we have this address allow list, and this allow list gets added to this mapping S voters. Okay, so we loop through this allow list, we add to this mapping here, and this is how we decide who are the voters. So it's not like a DAO where you hold the token. It's a DAO where right in the contract creation phase, you say, these are the allowed voters. These are the people who are allowed to vote. That's basically what this does. And then there's also a creator who's going to be our message.sender. And this constructor is actually payable. So when this contract gets created, you create it, there's a minimum amount of funding. You need to fund it with at least 1 ETH. And then these people vote on where to, on where to send it. So there's right in the constructor, we say, okay, allow list, total voters, creator, and then we say, and then in the voting, hold on one second. And then the voting, we actually send the ETH to these the people who got the votes. So that's pretty much it. And in this vote function, when we vote, once the total votes is past whatever the minimum quorum is, we call this distribute rewards function down here. And if the total amount of votes against is more than the votes for, we send the ETH back to the creator. We send all the money back to the creator. If not, we give the people the money, right? So basically, if the vote doesn't pass, we reset. If the vote passes, we send the money, right? And we can even read here, proposal creator is trusted when creating allowed list of voters. Findings related to gas griefing, attacks, or sending ETH to an address reverting, thereby stopping the reward payouts are invalid. Yes, poll to this is preferred to push, but this has been implemented in a simplified version of the complex contract. So I probably need to add that to known issues. Equius. Sorry, I should add that. If at the last voter roundup, if comments a little bit confusing. There's a little bit of rounding up in case there's leaving some dust. This means that the last voter will get one way more than the rest. This isn't a valid finding. This is just part of the code base. I need to add that to known issues, Equius. Sorry, I didn't add that already. But that's it. That's all this code does. You vote. If it passes, boom, you send the money to the people that it passes to. If it doesn't pass, boom, it goes back to the creator. That's it. So it's been intentionally simplified. Please read the comments carefully as they note specific findings that are excluded from the implementation. I need to add some of those to the known issues at the bottom. Sorry, I did not add those yet. But yeah, the big hint is cats are fuzzy. You can find the bug here just by making the test suite better. That's it. So for those of you who are like, oh, I can find this with manual review, but you're not that good at fuzzing, use this as an opportunity to get good at fuzz testing. Because basically at Cyfrin, if you do not have fuzz tests in your code base, we tell you straight up, hey, you shouldn't deploy until you have fuzz tests. So you should get good at them. We've also used fuzz tests. We've said this many times. We use fuzz tests to literally close our eyes, find bugs without even doing manual review. everyone should be doing fuzz tests at this point. So get good at use this as an excuse to test out your fuzzing skills. Obviously, we have the quick start, Forge install, Forge build, Forge test. The coverage on this is pretty good. There's not a whole lot of weird stuff here. We have a Sulk version. Deploy this to Arbitrum. Yeah. So I lied. There's more than one high, but the biggest high is can be found with fuzzing. Anyways, so that's pretty much it. Real minimal code base. Vote. Get sent the money or not. So now we can. I know this was super quick, but now happy to take any questions here. Okay. Thank you for being here. Like a one-time use, kind of. So it actually resets if it fails. So a one-time use, basically, yes, but you can vote again if it fails. Patrick, I recently started working on first flights. Do you suggest me start right from this one or start working on previous flights through the Updraft security course? So in the Updraft security course, we go over a lot of the previous first flights, right? We go over password store. We go over puppy raffle. We go over T-Swap, which actually hasn't been a first flight yet. We go over Thunderloan. We go over Boss Bridge. So we actually go over most of them. So I would say just start here, right? So the purpose of these first flights is to give you a better sense of, hey, what these competitive audits are really going to look like and what they're going to feel like. And additionally, when you go to a private audit, or if you ever do, it'll give you a good idea of what those feel like. Or if you're like, hey, I don't care about being a security researcher, I just want to get better at Solidity, it gives you a good understanding of what these feel like. And there's a bit of a pressure that you don't recognize before doing one, that you go, whoa, this is cool. So no, just start here. Start from here. Great question. How to set good invariants. This is a phenomenal question. So this is actually something we've been experimenting at Cypherin with, pumping the READMEs, pumping the documentations into AI and saying, hey, give me a good invariant. Our tests so far have been a little inconclusive. The AI has not been that reliable on giving us good invariants. But really, this is kind of up to you, right? This is the human superpower at the moment. Reading the docs, saying, okay, what is the property of this system that must always hold? Right? No matter what functions are called on this system here, what are the properties that should always hold? And that should be the first thing you think of here, right? No matter how many times people call vote, what should always happen? And that's how you're going to want to define your invariants. Definitely going to practice fuzzing. I'm scared of handlers. With only one function, can I avoid stateful tests? LOL. So here's what I'll say. So in the course, my terminology is actually a little poor. I said handler-based stateful fuzzing and then open stateful fuzzing. Better terminology would be guided and unguided. It's on my to-do list to actually work with you, Acquiesce, to update some of those. For this one, I would recommend you can fuzz this with unguided stateful fuzzing. So stateless fuzzing will not work here. This needs to be stateful fuzzing. Whether or not you use guided or unguided, you'll actually find pretty quickly, if you try to use guided fuzzing or handler-based fuzzing, if you will, it's kind of a waste of time. Just because there's only one function to call, right? There's no tokens, there's no oracles, there's no kind of external systems where you would need to do guided fuzzing. So using unguided stateful fuzzing will totally find the bug here. And that's kind of your cue of what type of fuzzing to use, right? What external contracts is this code base working with? If there's no external contracts, okay, well, maybe you just do unguided fuzzing, right? And in this one, there's no external contracts, so maybe unguided fuzzing works. However, there is ETH at play, right? So when we deploy the constructor, there's a little bit of ETH at play. So maybe you do some guided, but I'm going to tell you right now, you can solve this with unguided fuzzing. Good question. Cool. Any other questions here? Yeah, this is a very quick first flight kickoff. This is a minimal code base. I said there's only one high. I lied. There's at least a high and a medium. I should just shut up. Never mind. Don't listen to me. There's at least one high. There's at least one high. Any other questions here? That was a great question, Acquiesce. Well, if there's no other questions, then I wish you good luck. I hope you find all the bugs and a low. There's probably a low. Yeah, there's probably a low in there. You know what? There's probably tons of bugs. All right. Well, thank you for being here, Coffee. Appreciate it. Well, if there's no more questions, good luck. Happy bug hunting. I hope you find all the bugs. This one's not themed like our Santa's list, which definitely everyone should go check out the results for that one because we slipped a very sneaky thing in there. That was very fun. So looking forward to some write-ups on that as well. All right. Thank you all. Happy bug hunting. Ciao.